Okay, so members, now we are going to have a different question. Now we are going to see a first one of a pyramid, which is going to be a bit technical. So please don't forget to subscribe to the channel. Okay, now we are here, we are having that in the figure below, AB is 8, BC is 6 meters, and V, CV, AVB, and VD are equal to 13. M is a point on VO, this is VO, such that 3MV is equal to OV, and M is the center of ECF, this base. Now, calculate the height of VABC. Now, calculate the height of VABCD. So this is the pyramid that we have. So calculate this height. Now, if I want the height, it's V. Then I'm going to pull out this base. Then this vertex here, like this. Now, to calculate this height, is that I need to get this length here, but this length is going to be a half of AC. So meaning I need to get AC first. So from here I start now, my AC squared is going to be AB squared then plus BC squared. So now my AC will be the square root of AB, which is 8 squared then plus this, which is 6 squared. So that my AC is going to be 64.36 root. It's going to be now 10 meters. So if I have AC, now I can get OC. From here now, using now VOC, using VOC, this is the triangle I'm going to be with. This is my VOC. Note that our OC is going to be a half of AC, which is going to be a half times 10, which is 5 meters. So now here I have 5 meters, and then this is 13 meters from this diagram. So now it's at my VO, now my OB, so that from there, my OB squared plus OC squared is equal to VC squared. So that now my OB is going to be the square root of VC, which is 13, squared in minus 5 the whole square. So that my OB is going to be, that one is going to give you 144 square root, which is 12 meters. So now the height of this is that. Then they're asking me to get the dimensions of EFG. EFGH. So this I want to get these dimensions. Now, to handle that, I need to use some bit of similarity. Now, note that I'm going to use the triangle VOC. Now, using VOC, Roman numeral 2. Roman numeral 2. Now that if I use VOC, using VOC, that triangle there. Now, this triangle VOC, but it's going to be having this. But remember, this is the midpoint of, OB is the midpoint. Meaning, if I bring out it like this, now you see that this is what I'm going to be with. Not that. This is my O, this is my V. And note that from here up to here is going to be 13 meters up there. Now, to get the dimensions, of course, if I know these dimensions, if I get this now, I can use similarity in those two triangles. So now, I know that now V, this is my M here. I don't mean that. Now, they don't mean that 3 VM, 3, is it MV? Yeah, 3 MV is equal to OV. So I want to get my MV, it will be OV, we have got OV as 12, divided by 3, which will be 4 now meters. So meaning, for here, I have 4 meters. I know that from there up to here, they are 12 meters. Now, I'm going to use that similarity so that I can get this MG. This MG here. This is MG. Now, if I call this L, now I'm using similarity. Using similarity. Now, if I use similarity, you see that I'm going to say the big height over the small height is going to be equaling to the big slanting side over the small slanting. Now, let us see. So the big height, we see it's 12 over the small height, which is 4, equaling to the big slanting, which is 13, over the small slanting, L. So that this triangle VMD is similar to VOC. This one, they are similar. So now if we cross multiply there, start here, I'm going to be having L is going to be, okay, by this one, and this is 3. So I have 3L, so it's going to be 13 over 3. So mean that if I have now L, I can come and then note. I'm going to use now VBC. Now here, using VBC. Now to use VBC, note that my VBC is the whole of this. So if I'm to put it here, the VBC. So V, this is V, BC. Note that it has G here, it has F. I'm interested in this dimension FD. Okay. Now I know that my VD here. I have my VD as L. This VD is L. So my VD there is 13 over 3. Then I have this BC as 6. Then I need this. Then I know from here up here it's going to be 13 meters. So now there I can use similarity. I have this and this. I have this and this and this. So there is similarity. You see that I'm going to say similarity. Still using similarity. You see, I'm going to say now FD over 6 is going to be equal to FD, the small one, over the big one is equal to the small one, 13 over 3 over the big one, which is 13. And so, note, allow me to divide this here. I'm going to divide these parts here. Now we see, if we cross multiply, this is FD. So that if we cross multiply by FD, it's going to be, allow me to cut that off. FD is going to be, you see this 13 is going to cancel, our FD is going to be 2 meters. Now still using similarity, it means that now I mean that FD is equal to EH, because this one here is equal to this. So, meaning that this one is also equal to EH. Now missing EH. So I'm going to use similarity. Triangle VAB. Now using VAB. Now that triangle VAB, I'm going to have it here. VAB. This is A, this is B, this is RB. So note that from this we have A, F, and E. So if you have them there, remember that this side here, VG, is equal to this. Of course, this one is equal to this. So note that this one, FB, BF is going to be also 13 over 3. But remember the road from here to here is 13. Now my FB, rate is 8 meters. Now I can also use similarity. That now my BF over 8 is going to be equal to 13 over 3 over 13. And so this will cancel. So that now my BF is equal to 8 over 3, which will be the same as EF. Now that EF is equal to HV, is equal to HV like that. So now the dimensions are, the dimensions of EFG H are, you can give it as 2 by 8 over 3 meters. So if I have the dimensions, now they want to get to me, they want me to get the volume of the remaining part, VABC, when VEC is cut off. Now the volume, now this is Roman numeral 3. Now that volume is going to be volume of V of the remaining. Now the volume of the remaining when VE, when we cut off VEFVH, when we cut off, they want us to get the volume of the remaining thing. So volume of the remaining parts of the remaining parts. Remaining parts is going to be, we shall get the volume of the this big pyramid minus the volume of the small pyramid. Then we shall be having the answer. So volume of BC, then minus the volume of VEFGH. So if I get the volume of the big, then I get the volume of the small, I'll be having the volume of this remaining part. Now look at the volume, the formula I'm getting now, this volume is going to be R5. Then times, remember the formula for getting the volume of a pyramid is R5, the base area. So the base area here is going to be H times 6. So H times 6, then times the height. The height from here up here, which is VO. Our height VO is 12. Then all of this we are subtracting off R5 times the base area. The base area. So now we have the base area. We did now this times this. We have FD, which is 2. So 2 times 8 over 3. This times this. That's the base area. Then times the height. Our height. Remember the height of this smaller one. You see that was 4. So 4. So this now our volume will be, I think you see by this one, by this 4. So we have 24 times 8. 24 times 8. So here I have 192. Then minus, what do we get here? This is going to be 8 times this is going to be 64 over 9. So minus 64. The whole over 9. And so our volume is going to be 192 minus 64 over 9. Okay. So yeah, the formula as I'm getting is 84.8889 meters cubic. So now remember, it means that if we cut off the upper thing, the volume of this remaining thing is going to be that. Now in some questions, they are going to give you this, then they give you some dimensions, and then they ask you to get the volume of the thing that was cut. So that's it, members. I think I've exhausted all the pyramid questions. I wish you the best.